So I think you got the diagram and I think you understood the problem also, right?
So can you explain it?
Yeah, sure. So here a ladder 5 meters long is leaning against a wall. So let's take this is a wall and this is a ladder, right?
Yeah.
Okay, this is surface. Okay, this is ground. Now here is this is ladder. There is a ground. So it's obviously this 90 degrees. The bottom of the ladder is pulled. Now this bottom of the ladder, this is bottom, right? This is pulled like this. When this is pulled, what will happen? Then it will come down like this, right? This will come down like this.
Yeah.
Yes, like this it will come down. But this is pulled along the ground away from the wall at the rate of 2 centimeters per second. Let's say this is x, let's say. Now this is increasing, right? This is increasing like this, it is increasing, right? It is increasing.
Yeah.
So now let's take this this length as x, then automatically this will increase. So that's what he's saying. So ladder is pulled along the ground away from the wall at the rate of 2 centimeters. That means what? dx by dt is given as 2 centimeters per second. First thing.
Yeah.
How fast is its height on the wall decreasing? This is the height, let's say this is the height. Now this is decreasing, right? This much decreased.
Yeah.
So now decreasing. So what is asking? So he's asking dh by dt is how much? That's the question here.
Yeah.
But at what point? I told So this is rate of change means at what point? So when the foot of the ladder is 4 meters away from the wall, foot of the ladder, that is what this is. Foot of the ladder is 4 meters away from the wall. This is the wall, and this is 4 meters. So this dh by dt is how much? Is the question when x is 4 meters.
Yeah.
When x is 4 meters.
Yeah.
So x is 4, this is in meters and this is 2 centimeters per second. I already told this rate of change is generally it's a small thing. So delta x, we say, right? Delta x, that is what it represents a very small. So this is 4 meters. So now let's say L is the length of the ladder. L is always constant, yes or no?
Yeah, right.
That is the thing now. So here, what is that? Here, L is constant. That means what? X square plus H square. This is right angle triangle. Therefore, L square plus H square is L square, which is this is constant. Here, X is changing, H is changing, but L is constant.
Yeah.
That is the thing.
Yes.
This L is given as 5. So therefore, what you can say is this is a relation. X square plus H square is 5 square. This is a relationship. So if you differentiate what you get, then it is done. Then 2x dx by dt plus this is 2x dh by dt equal to what? 0. 25 is what? 0. Right? What we want? One we want 2h into dh by dt equal to minus 2x into dx by dt. So 2. So we want this one, but here what is x is given? When x is 4 centimeters, what is h? From this you get when x is 4 centimeters, what is h? X is 4 centimeters. Here h is 3. That's what you should substitute. So dh by dt, then you got dh by dt is what? X. Okay, what is that x? 4 and by h is 3 into dx by dt. What is dx by dt? 2 centimeters. Be careful. 2 centimeters means what? How many meters?
400 centimeters.
2 centimeters you have to change to meters.
2 centimeters to meter. 0.02.
0.02. So that means what? 0.08 by 3. Okay, this is what is rate of change. So therefore, what you can say, dh by dt, which you need to find out, dh by dt equals 0.08 by 3. What is this? Meters per second. Okay, or
Yes.
this is given as centimeters. So this one you can change as centimeters. So what you can write if it has to be in centimeters, simply 8/3 centimeters per second. Yes, sir.
Yeah.
Into 100 I did, that's it.
Yeah.
No problem, that way also. So this is what. So here you need to understand h and x are variables and L is constant. Okay.
Yeah.
So
Yeah.
relation between h, x, and L.
Yes.
Okay, shall we go to the next one?
Yes, sir.
Right. So 11th you said, na?
Yeah.
Okay. 11th is okay. This is direct one.
Sir, I didn't understand what the question is saying.
Yeah, okay. A particle moves along the curve. Okay, this is cubic, na? So 6y equal to x cube plus 2. This is a curve. That means what? Y is generally f of x. So here f of x equal, you can take that 1/6 times x cube plus 2. You can take f of x or y. This is y or f of x. Find the point on the curve. Okay,
So how did it become 1/6?
this 6 I brought this side.
Okay.
6 times of x cube plus 2. Y or f of x, which is same.
Yeah.
Find the point
Yeah, okay.
of the curve, right? So this is a curve maybe like this. So somewhat I drawn just roughly I drawn. Find the point on the curve at which the y coordinate is changing. So let's say this is the point on the curve, okay, or wherever, maybe this is a point on the curve. Okay, y coordinate
Yeah.
changing 8 times as fast as x coordinate. Now let's say this is x comma y. Okay, so here
Yeah.
y coordinate is changed. That means what? dy by dt. Okay, you have to find out
Yeah.
the point. That point, let the point be x comma y. What's happening here? The y coordinate is changing. That is dy by dt. How it is changing? Is changing 8 times as fast as x coordinate is changing. Dx by dt.